Every day we make a choice to recycle, to compost, or to simply discard an item. But regardless of what decision the consumer makes, corporations are one of the biggest contributors to environmental damage.
Recycling and composting and all that stuff is great, but it's not where the real problem is. The real problem is the way we make things and move things around. It's the factories and the supply chains. If you want to reduce waste in the world, that's where you target.
Reducing waste is an ambitious challenge to tackle, but it's one Steve Pratt, founder and CEO of Noodle.ai, is facing head on. The strategy? Use artificial intelligence and machine learning to help manufacturers and supply chain distributors limit the amount of waste they produce every single day. On this episode of IT Visionaries, Steve explains just how much waste is produced yearly by industrial operations and the monetary ramifications that waste brings. He also explains the way his team is using AI to help manufacturers predict hiccups with their machines, and why it's time for users to overcome their fear of AI. Enjoy this episode.
IT Visionaries is created by the team at mission.org and brought to you by Salesforce Platform, the #1 cloud platform for digital transformation of every experience. Innovate fast, empower every employee, and scale with confidence from anywhere, with a customer at the center of everything you do. Learn more at salesforce.com/platform.
Welcome everyone to another episode of IT Visionaries, and today we have the CEO of Noodle.ai, Steve Pratt. Steve, welcome to the show.
Great to be here.
All right, let's dive right into it. We did a little homework. It looks like Noodle.ai is leading in a new field that is you are dubbing Flow Ops. Tell our audience, what is Flow Ops?
Flow Ops is all about applying advanced machine intelligence, combining with the best of human intelligence to create a world without waste. What's different about it than traditional enterprise software is that it predicts waste before it happens and allows the users of the software to go in to eliminate the waste and generally do good things.
So this is a new way of framing up a tried and true problem in manufacturing supply chains. It's usually approached at, I always feel like, with the concept of money. Like, if you waste, you're losing money. But you are talking about it from waste, a world without waste using flow operations. For our audience that doesn't know, maybe they're working in different industries that don't have or run the risk of having waste costing their business. Talk a little bit about what is happening in a modern supply chain. Like on your website, you've listed Reckitt Benckiser, Kellogg Cereal, Estee Lauder Cosmetics. Talk about what is happening inside of a manufacturing supply chain that causes waste and what it looks like on a scope and size and scale of waste. How much it costs these customers you have before they solve the problem. How much does it cost them?
Yeah. So the answer is about $2 trillion a year.
Oh.
And that's just in three areas. There's one area which is excess inventory within the supply chain, that it's people, companies sending the wrong materials to the wrong place at the wrong time. That's about $446 billion. There is about an $861 billion problem in the factories themselves, where people or the factories produce defective goods that are thrown out. That's an enormous problem. And then there's unplanned downtime in factories that to make up for the unplanned downtime, companies have to create all kinds of wasteful things. And that's about $689 billion. So just those three problems right there is about $2 trillion a year. And it produces about half of the waste in the world every year. Just those factories and supply chains. It's quite extraordinary.
Yeah, you guys, Noodle.ai is approaching this not only from the business software side of things, but it's also approaching it from this environmental impact concept, which you just kind of hinted at. Like, so you're saying you've seen studies that half the waste that is discarded into the environment is actually from miscalculations. Is that the best way to describe miscalculations in the supply chain? Like, why is that being created?
Well, from industrial sources.
Gotcha.
There are some studies, in fact, an often quoted study, I believe it's from Johns Hopkins, at one point had it at 94% of the world's waste coming from industrial sources.
Wow.
There's another one. So we're taking the very conservative that let's just call it, 50, right? Half the world's waste is from industrial sources. And And, don't get me wrong, like recycling and composting and all that stuff is great, but it's not where the real problem is. The real problem is the way we make things and move things around, right? It's the factories and the supply chains is, if you want to reduce waste in the world, that's where you target. The intention of Noodle as a company is to create a world without waste. So that's where we go, where the waste is.
Yeah, let's take our audience through that journey. Like, how does so much waste get created? How do these systems? Because you would think, from an outsider's perspective, you would think that a manufacturing supply chain is super optimized, that everything that goes in ends up in the products, that it ends up on the shelves, that the plant is only making what people want to buy and sell. We don't think of a plant as over ordering materials, not producing enough product on the other end, and not getting to shelves and not getting consumer hands. Talk a little bit about what is happening today so that our audience can conceptualize just how much waste. I mean, the numbers are staggering, but kind of walk us through like what happens.
Yeah, well, you're right. I mean, no one ever ordered a factory to be built and said, "Hey, can you throw in some defective products in there?" I'd like some defective products to come with that factory. That doesn't happen. So what happens is that you get your raw materials from your producers, right? And there are variations in that it's not consistent. And so that's one input. You also have a factory that is, has some aging parts, the weather's different, all these variables, what we call features that impact what comes out the other end of your factory. And up until today, right, the software was written when computers were really slow. And so they just assumed it was always the same. They assumed the weather was always the same, the raw materials were always the same, the factory is always the same. And it was kind of perplexing that like different things came out the other end, like some were good and some were defective, and couldn't figure out why. It was just this perplexing thing that, in fact, we've named it. We've called it operations entropy, just like this chaos that comes out the other end. And but what happens is that with high performance computing and lots of data, that you see that these things are not random, and that there are patterns, and that you can actually decode those patterns and to say, you know what, given this relative humidity outside and this weather and this set of raw materials, that if we produce these products, they're going to be defective. So we need to adjust the factory, and so that we'll produce products that are meeting the specifications of the customer. So that's one giant area. I mean, that right there is $861 billion. And so just being able to not get things out the other end and look at it and say, hey, this is defective, and then throw it out, right? And that's an enormous problem. The other problem is on even if you produce perfect products, right? That getting the products to the right place at the right time, you would think is an easy problem, but it's a really hard problem. In fact, over 40% of the food that's produced in the world is wasted. It rots or is thrown out. And we have water we have plenty of water collectively, but it just happens to be in the wrong place at the wrong time. And these are really, really complex math problems. You get to a complex consumer goods company, could have 1,000 SKUs, could have 100,000 SKUs. We have one customer that has over 100,000 SKUs, has to figure out how to send those to, over 50 different countries. And traditional software, like if you have ERP, if you've got SAP or Oracle, it is just not architected to handle these problems. Those systems basically assume that your plan never changes. And so you get these, your air freighting stuff to overflowing warehouses. And on one hand, on the other hand, you've got empty shelves in another place. So, I mean, these are giant problems, and it needs better technology.
So from a technology perspective, talk about that, because the supply chain receives data and inputs from so many different places, and you already hinted at it, which is a lot of manufacturing facilities, they're not even modernized yet. Like there's some that are, of course, we think of ultra modern, sleek factories, but that there are plants that are relying on, let's say, legacy technology. It might not even kick off data. It might just be a machine that doesn't kick out. There's no APIs. It doesn't have a computer, doesn't kick out data. I'm sure there's plenty of those still in the world in circulation and in use right now.
Yeah.
If I think about it from a high level 10,000 foot perspective, if I'm building a software, how do you even begin to collect all the inputs necessary to make a decision? Because you said yourself, right? You need the data, first of all, to recognize that there's a problem or there's a way to solve it.
Yep.
But then I think about in a supply chain, man, there's a lot of systems that actually kick off no data, not in a digestible format yet. Am I wrong? Or talk about how you approach this problem.
Yeah, I mean, you'd be surprised how much data is out there. It's just in data jail. I mean, let's talk these factories. I mean, most of the world's factories have sensors, right, that are recording data on what happened in plant operations. And there were previous waves of technology that came along. One called data historians, right, who basically just, you can think about it. They collect your data and they put it in a dusty library that just sits there. Right. And right.
Just rows of file cabinets.
Right. Exactly. That's a mental image. It's like that scene from Raiders of the Lost Ark where, like you're trying to find the Ark of the Covenant is buried somewhere in this warehouse. But anyway, so the trick is and we've developed some real breakthrough technology on the data side of extracting those data to really be able to analyze it and to run very sophisticated algorithms on those sensor data to figure out defects, to figure out when the factory is going to break down so you can repair it ahead of time. So that's on the factory side. On the supply chain side, I mean, it's amazing how much data is in these ERP systems. We are absolutely building our applications on the shoulders of ERP systems. And thank goodness that companies spent the money they did to put in these ERP systems. So we take, like, for instance, SAP. SAP has two modules in supply chain called APO and IBP. And so we love those systems, right? So especially if you have IBP, right, which is the more advanced one. So we ingest the data from that. We bring in a lot of external data and basically run it through very sophisticated algorithms. And, we can simultaneously increase what's called the service level, the amount of, basically reducing empty shelves while reducing inventory, which is really an extraordinary thing, right? And, the pioneering companies like the ones you mentioned, like Kellogg's and Estee Lauder and RB are seeing, amazing results and, economically, and it's consistent with their mission, which is to help reduce waste in the world. I mean, it's a really, really important thing.
No doubt about it. Now, how did you take us back a little bit into your background of how you, let's say, I don't know if the best way to frame it is like recognize the problem.
Yeah.
We read articles about you leaving, you went from IBM. It sounds like you headed up IBM's Watson Global Business Services unit. And then from what we read, it looks like you started Noodle.ai shortly after leaving that. Is this a problem you learned while at IBM, or was this a problem you learned about in previous stops?
Yeah, I mean, it's one of these things where a whole bunch of things came together into a giant aha moment, which actually happened to happen in the jungle of Panama, but that's like sort of a different story.
No, we got to hear about that. That sounds interesting.
I'll tell you about that. So I will say that I learned a lot about business operations, way supply chains and factories work, and spending a long time in enterprise technology, right, in management consulting, and just understanding what's important to companies and where the waste is, and getting frustrated that there wasn't a better answer. Mm-hmm. So that was that sort of framed the problem for me. The solution, I actually have to go further back into my career. Actually, when I was doing kind of spooky stuff for the government, right, in the 90s, where I actually applied some early AI to try to find which ships off the West Coast were drug smugglers.
Wow.
Right. So we would put in the tracks from the ships that were coming, into California, and run this AI system on a system called Lisp. And basically it would try to calculate which ships were drug smugglers. And I thought it was like freaking amazing that you didn't have to write the rules, that the computer figured out the rules, and it would tell you which ships were drug smugglers. The problem is that the computers were so slow, the ships were usually long gone before you could tell like that was a drug smuggler, and you burned up so much money on each time you ran the computers, and they would usually crash. But I thought it was like, this is an amazing thing, the fact that computers could learn.
Yeah.
And that they could. So I said, like, that's got to solve a lot of problems when the technology gets here. So I think that computers finally got fast enough, the data got cheap enough, and the mathematics had advanced enough so that around 2012, 2013, 14, we crossed a threshold where these things were possible. So, all right, you want to hear about the Panamanian jungle stream?
Yeah. So you figured, you're a young guy. You're a young guy catching drug smugglers. You
Right.
figure out the computers can help you identify it. Now you were a little disappointed because by the time you got it processed, you're like, hey, the smuggler is at point A. And then you're like, the person's not there anymore. It's like, yeah, they were there like 6 days ago.
Yeah, exactly. Exactly. And then you need a really fast bus to chase them out into the ocean, right? Like which is no joy, right? So
right. So that brings us now, like, sounds like we now understand you've been fascinated by computers and the power of compute learning to educating itself, artificial intelligence. Now you're just in the jungles of Panama, and what happens next?
yeah, so I'm in the jungles of Panama, and I was trying to figure out what I wanted to do next, right? And this was in 2015, I believe, and it sort of dawned on me that there's this giant problem, and then there's this really powerful answer, and that's something that I care deeply about is making an impact on the world. And I'm a big believer in the regret minimization framework,
Okay.
which is that you should go do something that when you're sitting on your porch when you're 90 years old or whatever, however old you get, right? And you look back on your life, you say, like, that was pretty cool that I did that. I was proud of myself, even if it failed, right? I went for it. So anyway, I'm sitting in the Panamanian jungle, and someone questioned me about, well, like, what was my superpower and what did I want to do? And I said, this is what I really want to do. And so I left IBM, right? And it's like a cushy job, right? Making a lot of money. I got fancy executive, and like I said, I want to leave my mark. I want to at least try. And so the idea came up for Noodle. I didn't have the name Noodle at the time, but I came up with this company that I wanted to apply artificial intelligence to create a world without waste. And then I came home determined to make that happen, and we did.
That's awesome. Were you an eco-tourist? Is that why you were in the jungles of Panama at the time?
Yeah, it was a place called Kalayalu, which is the world's most sustainable village. It's a trip. It's a wild place. I happened to be there with this group called Hatch, where they curate about 100 people to do these cool experiences, and I was one of the 100 people. And so, but it was actors and physicists and musicians, and it was brilliant. It was really, really great.
Listen, the smile on your face as you're telling the story just tells me all I need to know about how influential this experience was for you. When I think about, because I'm with you in that I'm a eco-tourist myself. I love surfing, so which means, of course, I respect pristine beaches, clean environments, and I've always thought to myself, I agree with, I want to be part of a solution rather than a problem. And you see these stats that are just really, really disheartening when it comes to like personal responsibility, kind of like what you were hinting at. Like, for example, if I were to recycle, like I use like, one thing of, let's use laundry detergent. I use one plastic thing a month with my family, right? Like buy the industrial jugs. So like,
Yeah.
if I recycle that one thing, but what you're talking about is in a mismanaged supply chain or manufacturing facility, like thousands of plastic buckets could be going out every day.
Yeah, I mean, it dwarfs that. I mean, let's take steel production. We do a lot of work in steel production. It's one of the dirtiest industries in the world, right?
Yeah.
I find it ironic because some people are like, you're a world without waste people. Why are you focusing on steel? It's so dirty. And like, exactly.
Yeah.
So if you throw out or downgrade a roll of steel, right, you go through the entire process of getting the raw materials, you heat it up, and then you get to the end and there's a crack in it, right? That basically, like, you've just wasted, so an electric arc furnace, right, which is a lot of steel makes, uses more electricity than a medium-sized city, right? So just to melt, like, a roll of steel, like the energy consumption is amazing. So, I mean, we're really proud of, like, we did a lot of work at a company called Big River Steel, which is since acquired by US Steel. They became the world's first LEED certified steel mill, which seems like an oxymoron. LEED certification, for those people who might not know, is as kind of the gold standard for environmental responsibility.
Yeah.
So we worked really, really hard with this company for many years, and they became the world's first LEED certified steel mill. We were really proud of that.
I want to go into this use case because what you just described, to run an arc furnace actually consumes more electricity to run one than in a small city.
No, medium-sized city.
A medium-sized city, right?
Like population 300,000.
Right. And so when people aren't too intimate about the knowledge of what it takes to make steel, and they hear like, oh, well, steel is like, it's infinitely recyclable. You can remelt it down and make more steel. You're saying, no, the energy consumption it takes just to make steel and remelt steel is so astronomically high just by improving its operation so that it makes less defective steel is actually the best thing you can do for the environment.
Yes. And also there's still a lot of steel made from mining, right? So you mine raw materials and you iron ore and then you melt it. But even these electric arc furnaces, which are technically steel recyclers, I mean, they take your old car and your old refrigerator and they grind it up. And there's these, wonderful companies that are in that business. Even if you're using this new process, it better be efficient, right? it better be efficient because we need steel, right? I'm not saying like stop using steel, right? Because we need steel. The population of the planet's pretty soon going to be close to 10 billion people. Yeah. Like they need houses and they need.
I read this article about how like more than 50% of the bridges in the United States need to be redone in some fashion.
Yeah. Yeah.
Like reconditioned something like something's not right with them, which is of course going to need a lot of steel.
A lot of steel. Yeah, exactly. Anyway, so we just, decided to go where the waste is and apply the most advanced machine intelligence to help it get more clean. And by the way, Big River Steel at the same time of being the world's first LEED certified steel mill also has the highest profit per employee of any steel mill in the world.
So let's go to that moment in time when they decided to talk to Noodle.ai and say, hey, listen, we think you can help us, right? So when, you say waste, I mentioned before, most people frame it in terms of dollars because waste is dollars.
Yeah.
If I'm a manufacturing plant, you say, hey, listen, man, I can improve your, quality so that you make less waste, so that you have less manufacturing hours that generate, more product hours. My ears are peaked. I'm like, all right, talk to me. How does this work? Talk to me about that first implementation. Like, what does it take to implement a solution like this? Because you mentioned before, you're going to need to tap into like that locked data you mentioned. I don't know if they were ready to have data transported because they had API systems, or this is one of those classic projects where you had to get your team in there and be like, how do we unlock this information? How do we get into our compute systems? And then once you figure out a result, I'd love to hear how a result gets implemented because I can't imagine it's just like, this isn't just a website. We're not clicking the, submit button and all of a sudden everything changes. I think it takes real people to implement the change it recommends. So I'd love to hear a customer journey lifecycle through your eyes at what happened.
Yeah. So we have 5 products, right? So we have, they're all named after creating flow, right? Which is the seamless flow of goods from raw materials to consumer. We have, asset flow, quality flow, inventory flow, production flow, and demand flow. So the first 2 are on the manufacturing side. So we have a lot of experience working in process manufacturing, heavy industrial. So steel, concrete, chemicals. A lot of those companies use something called IBA, which is a data historian. So we have connectors. We've invested a lot in technology to extract those data. And so basically once we sign the contract, we will go in and basically put our connectors into their systems, extract the data. It helps train we need about 3 years of historic data to analyze it. Well, we're generally up and running on the manufacturing side in about 5 months. It takes a while, right? Mm-hmm. On the supply chain side, it's a lot faster, right? So it's probably about 3 months. Most of that, as you said it exactly, it's getting the data, right? Getting access to the data. The thing that our customers tell us is, like that's amazingly fast, right? That typically when we talk about these large enterprise applications, it's 18 months, 24 months. It's sometimes upgrading some of your system, some of these big systems are, it's going to cost, 100, 200, $300 million and take like 2 to 3 years, right? And it's like, no. Like we're like 3, 4 months because it's already built. I will say that there's a lot of misperceptions about AI. And so, I mean, we can talk about those if you'd like, that is sort of related to this, right?
Yeah.
Yeah. I mean, one misperception about AI is that you just get a platform and you feed it data and all of a sudden
You get answers.
out pops this magical AI application. And people are buying into this
Yeah.
and wondering why. I think according to McKinsey, 80 to 90% of AI projects fail, right? It's because it doesn't work like that. It's like developing a sophisticated piece of software. So it's like saying, I bought software, like I bought like C++ or whatever. And why can't I develop my own custom CRM system in a month?
Yeah.
Right. It's like, these are complicated pieces of software. So all of our products have taken years and years to develop. And so I would encourage people to buy products rather than start a project. Right. So that's one thing is that AI is getting a bad name somewhat because people are starting with a blinking cursor and expecting to get results in 3 months. And it doesn't work that way. You have to develop it. So anyway, that's one thing. The other one, which is kind of a slightly different topic, is that people are afraid of AI, right? People think that AI is the Terminator or, it's going to, kill them in their sleep, right? It's going to decide that humans are inefficient and that it's going to do global Armageddon and destroy humanity, right? And there's so much attention to stopping bad AI.
Yeah.
And I'm all for stopping bad AI. However, I would rather put a lot more of my energy into creating good AI.
Yeah.
Right. And that this is a very, very powerful tool, right? That, there's a lot of people who are saying that, AI is going to eat software, right? And that most things are going to use learning algorithms. And I would rather spend my time creating good in the world with this rather than stopping the bad part. So anyway, I'm all for stopping bad AI, but
yeah,
let's focus on good AI.
Yeah. So, let's return back to that example. So you've implemented it. It took 5 months or longer, it sounds like, to get all this going. The tool is starting to learn. So what happens next? Like if imagine me, I'm the CEO of a steel mill.
Yeah.
I'm sure it comes out with recommendations like, hey, you should do this, right? Because it can't actually do anything, right? It doesn't, not that it can't do anything. It doesn't do it for me. You know what I mean? Like it's going to come out with recommendations, or how does it work?
It could do it for you.
Wow.
You could actually connect these things directly into the controllers in your factory, and it would adjust the settings in your factory automatically.
That's wild.
Most companies, I would say to date, all companies have decided not to do that. It could, right? So I actually believe that, and we have actually gotten to know Garry Kasparov. He's the world chess champion. He was 20 years, he was the best, chess player in the world.
Yeah. Were you part of the team that tried to build that IBM tool to beat him?
No, that was a long time. That was 1997, I think.
Okay.
Right. So that was Deep Blue. But yeah, Deep Blue, he beat Deep Blue first and then Deep Blue beat him.
Yeah.
But he has this concept he wrote in the Harvard Business Review about the combination of authentic intelligence, which is the human brain, artificial intelligence, which is math.
Yeah.
Combining to create augmented intelligence. And I believe that the human brain is much smarter than even the fastest supercomputers at certain things, like asking questions. AI is really, really good at calculations and providing answers. It's interesting because he started something called advanced chess, which is the best chess players in the world, plus the best chess algorithms in the world, teaming together against other human algorithm combinations. And those teams outperform the best humans and the best algorithms. So it's the combination of the human brain plus machine intelligence that is absolutely the best. And so that's the and I firmly believe this, that if I use my calculator I use it to do long division because it's just better at doing long division than I am.
Right.
And so it's knowing when to apply AI and how it complements the instincts and the questioning of the human operator. It's that combination that gets the best results.
No, that's awesome. And then, so going back to you said it could operate the control panels. It doesn't happen that right now. But like, I guess, is that the most common output of Noodle.ai is like you produce, I guess, recommendations? Like what does it produce?
Yeah, no, exactly. So it produces recommendations. It says you should change these set points in your factory, or you should inspect that piece of machinery, or you should, on the supply chain side, it actually creates these tasks that you basically commit back into SAP, and then SAP makes the changes.
Wow.
So there is a human in the loop, right? Because it's the best combination. There are 3 engines in our applications. Importantly, they're based on a relatively new kind of AI called XAI, which is explainable AI.
Mm-hmm.
So it actually tells you why it came up with a recommendation.
That's what I was going to ask you about, because a lot of times people see things on computers, especially like if it's a software I'm not familiar with. I'm like, I don't know. How'd you get that? That's I remember that being in marketing.
Yeah.
People being like, well, how'd you get that? It's like, well, do you want me to do this or not?
Yeah, no, exactly. And I can tell you that when there's safety issues or when people's careers are on their line, it's tough to go to your boss and say, yeah, the factory crashed. And like, why did it crash? And then it's like, well, the AI told me to do something.
They said turn it off. I just did. So, it's cool.
Yeah, it just did. Right. That's not, you don't want to be in that position. So what our AI does is that actually goes through and tells you, here's the reason for the recommendations. Right. And which is actually really, really coming up with the explanations is almost as hard as coming up with the original recommendation itself, right? Of why it's recommending this. But, I think it's a really, really important topic, just to make sure that, it increases the collaboration between the human and the algorithm when the algorithm can communicate to the human why it's saying something, right? So,
listening to you explain this problem, I don't say this much about many companies, but man, I'm looking at your current job board. I wish I could apply to one of them.
Yeah.
You're looking. So if you're a data scientist out there and you're looking to change the world, and I agree with you, like industrial waste it's a bigger lever to pull. As personal waste, personal responsibility. I'm all for personal responsibility. I think everyone should be personally responsible for their own waste.
Right.
But like Steve's already been talking about, there's more industrial waste than personal waste by far and wide.
Yeah. And I will say that, the other thing that was kind of a serendipitous thing is that the impact on the employees of our customers. Like if you're an inventory planner,
yeah,
like 2020, was a rough year.
Oh yeah, it sucked.
Yeah. I mean, you got blamed for everything. Why is this stock out over here? Why is this excess inventory over here? Like, what's the matter? You're supposed to be figuring this stuff out. And so there's like massive attrition in the planning community.
I didn't know that.
And there's brain drain. It's the morale is low, and it's because their systems feed them a bunch of nonsense. Right? There are so many alerts that come out of their systems that it's gibberish. And so when we put in our systems, we actually they can actually quantify the how much value they added to their company, and they go from being blamed for everything to being celebrated. And because we talk about team flow also, getting the planners and in the state of flow. And in the state of flow is the combination of high skill meets high complexity, right? And if you talk about world-class athletes, or in fact, Garry Kasparov talks about this also, like in chess, right? Getting into this mindset of deep concentration. That's what we want to get the people in the world who are responsible for running factories and supply chains to be in this deep sense of concentration, and basically to be able to deal with all these curveballs that are coming at them. And to me, that's the most exciting thing, is that our customers can recruit people, they can retain talent. And it's one thing that I wasn't expecting to see, but it's really fun to see the impact on these people's lives. And I was talking that we should shoot a TV commercial from the perspective of one of our customers' dogs, right?
Oh, how their owner's so much happier.
Right. Yeah. Yeah. They used to come home and kind of grumble and be like unhappy, and but they were just really unhappy. And now they come home and they're like, playing with them, rolling around on the floor and all, teaching them new tricks. And
you could also do a funny infomercial style where you come home to an inventory planner like, how did you plan your job today? I looked at a spreadsheet that a salesperson said that was going to, that they were going to sell based on last year's quota. It's like, wow.
Right. Exactly. Yeah, exactly. Yeah. I mean, it's amazing because current systems like ERP systems, even advanced planning systems, they assume that the factory is always going to produce the same amount.
Yes.
That the supplier is always going to be on time.
Yes.
That well,
it's especially crazy, like, because you have customers there. And, well, I mean, of course, I understand anything can be sidetracked, but when it comes to, like, for some of your customers that are in food production is wildly influenced by the weather.
Yeah.
Like you already said. I mean, it's wildly influenced. So, like, or raw material price. Well, we're seeing right now, like, lumber prices are going through the roof.
Yeah.
So it's very hard if I'm an inventory planner to say, like, oh, well, we still need the same amount of lumber. It's just going to cost us 10 times as much. Like, oh, you should have planned for that. How was I supposed to plan for that?
Yeah, exactly. Or, some ship gets stuck in a canal.
Yeah, Suez Canal.
Right. Yeah. Like you're like, right. Or yeah. And there's all these things and the ability to react. I mean, all of these problems happen in the last like 12 weeks.
Yeah.
From production to shelf. And that's when it's this what we call the execution window, right? That all the systems are designed for long range planning, but when it comes down to, it's when, all the crap hits the fan and like things are going all over the place, that's when flow is disrupted. And that's when you need to take these advanced systems to reestablish flow, right? And the fact that you can now do that, through these systems, these flow operation systems is, I think it's the future to the economy and the future to the planet.
Yeah. No, I love the way you describe that. Yeah. As a sidebar, housing starts are going to slow down. So housing prices are going to continue to skyrocket in every market because I think housing starts are going to slow down because developers can't afford all the lumber. This is the latest supply chain crisis I've been reading about. The lumber prices have gone up like,
yeah,
I've read almost 10 times in some places.
Yeah. And steel.
Okay. So construction's going to slow down and there's not going to be homes being built. Or because like if I'm a developer, I'm just going to slow down my build. I'm like, I can't build it.
Yeah. No, exactly. Yeah. It's upside down, right? I mean, the economics are upside down.
No, this is fascinating stuff that Noodle.ai is tackling. Right now, Steve, it's time for the lightning round. The lightning round is brought to you by the Salesforce platform, the #1 cloud platform for digital transformation of every experience. Steve, this is where we ask you questions about your life so our audience can get to know you outside of the world of Noodle.ai. Are you ready?
Ready.
All right. So this comes from research we did. And by research, I mean looking at your LinkedIn profile and putting together some hypotheses. Okay. So let's start with Northwestern. You list many intramural sports, and you also list yourself as a former member of the rugby team. Are you still an avid sports aficionado?
Yes.
Big sports fan. What do you enjoy watching, playing, doing?
Mostly tennis. I am obsessed with tennis, and I've been playing since I was a little kid. Since my first time I ever played tennis was when I lived in Tokyo on grass courts.
Wow.
And so I love tennis. I enjoy watching rugby, right? It was funny when I first started playing rugby at Northwestern, I didn't even know the rules. I just did it to stay in shape. And I was really fast back then. So and I scored a couple tries and they're like, you're on the team and we're playing Michigan on Saturday. And I'm like, University of Michigan, there's like big guys.
Yeah.
Right. And well, could someone teach me the rules? Right. So anyway, so those are my main sports right now.
Do you currently play rugby?
No, it hurts too much now.
Do you have a funny little joke on your LinkedIn profile regarding George Washington University where it looks like you went and got your undergrad? It looks like you got your undergrad in, I'm assuming electrical engineering and satellite communications. And you have a funny little joke. It says, seemed like a good idea at the time.
Yeah, no. I got my master's. And
oh, sorry. Master's. Yeah, there.
I got my master's at George Washington.
Sorry. I was reading that upside down.
Yeah. And it was like, yeah, I got this degree in electrical engineering and I didn't really learn anything practical. Maybe I need to get a master's. And I was working in satellite communications at the time. I was doing highly classified work for a bunch of agencies in Washington, D.C. And so I got a master's in satellite communications. And then I got to the end of my master's and said, like I still didn't learn anything practical. I just learned a lot of theory. But, in retrospect, it's interesting because the mathematics in digital signal processing, which is signal to noise ratios and finding signals in noise, is very similar to the math in AI, right? I was shocked by when I got more into artificial intelligence, the mathematics, it's all about entropy and information theory. And it's really interesting stuff.
Now, we alluded to earlier that you are a environmentalist and you went on a trip to Panama in the jungles. I'm assuming you've done quite a bit of ecotourism. Where are some other, when travel opens up, we always like asking this question. For someone who likes ecotourism, they want to see big natural beauty. What are some places that you've been that you'd recommend for someone who has, who wants to go on an adventure?
Oh, wow. I thought Croatia was amazing.
Oh,
right? Spending time in Croatia. I mean, growing up, we spent a lot of time in the Virgin Islands, right? Going in a sailboat and sailing from island to island. Some of the best bars in the world, by the way. Right? Like you just kind of sail up into the harbor, you kind of swim into the beach, and it's really beautiful. Thailand, some of the landscape in Thailand is extraordinary. I mean, the way the cliffs come into the water, almost like the sheer drop into the water, is really, really beautiful. I also have a soft spot in my heart for Japan and Switzerland. I lived in Switzerland when I was a little kid, in Japan when I was 9 and 10. So some extraordinary natural beauty in those locations.
Yeah, were your parents military? Like, what caused you to live in so many different places growing up?
No. My dad worked at Caterpillar. I'm a Midwestern guy from Illinois, and so when I was 3, we moved to Switzerland, and I was 9, we moved to Tokyo, and then back to Illinois.
Man, this is a life well lived, Steve. It's been awesome having you on IT Visionaries, sharing what you're doing at Noodle.ai. Thanks for sharing your insight and wisdom. And like I said, I don't usually do this, but if you're a data scientist out there and you're looking to make an impact, go check out Noodle.ai. I was getting fired up listening to you talk about some of the problems you guys are solving. Like I said, I went and looked at the career page and I was like, wow, I don't qualify for any of this, but
great. Well, I really appreciate it. Had a good time.